So these are the notes on Table F. Table F is called the Solubility Guidelines for Aqueous Solutions, and it basically tells you if something will dissolve in water or not. It will not tell you how good something dissolves in water because different chemicals will dissolve in water to different levels. That's actually Table G, which will be our next table, but this one just says if you dissolve in water or not. Now, how do you read this table? It's pretty simple. It's broken up into two halves. The left half form these compounds dissolve in water all the time, except when they're with something to their right directly. Then they don't dissolve. Compounds here on this side, the right side, will never dissolve in water, except when they're with something to their right, and then they do the opposite. So Table F looks like this on your reference table, and I color-coded it the same way. These ions form soluble compounds, so these guys dissolve, except when they're with something to the right. So if you notice this whole section up here, they don't have exceptions, so therefore they always dissolve without exception. These two at the bottom, they always dissolve, except when they're with one of these. You have to pay attention to the oxidation state. If the metal is not the exact oxidation state that's listed here, then it does not count. This side, they form insoluble compounds. So these guys will never dissolve except when they're with something to the right. Now you have to be careful because on some of these they say group 1. So that is the entire group 1. So that is from lithium straight down on the periodic table. So be aware of that. It's not simply one element. It's 5 or 6 elements that count in that. So be aware of that. So here's the way it works. When you look at these problems, so HNO3 is our first one. All you are going to do is find any part of this compound on Table F. So it turns out NO3 is on Table F right here. It's a nitrate. It always dissolves. There are no exceptions. So if you put HNO3 in water, it will dissolve. So the symbol we use is aqueous, or you could write soluble. It means the same thing. Next one, phosphate or lithium phosphate. So PO4 is over here, and PO4 does not dissolve except with group 1 or NH4. Lithium is in group 1, so this one actually does dissolve. Ammonium nitrate, well, it doesn't matter which one you look up because NH4, they dissolve, no exceptions, and NO3 dissolves, no exceptions. So this one also dissolves. Calcium carbonate. So you can do it, in this case, you find carbonate, the CO3 is on Table F, it's up here. It never dissolves, except when it's with group 1 or NH4. Calcium is in group 2, so this one, if you put it in water, it would sit there at the bottom, like if you put a rock in water, it wouldn't do anything. It would just sit there and nothing would happen, so it would be a solid. Calcium phosphate, so phosphate again, we find it here. Calcium is not in group 1 and it's not NH4, so this one will not dissolve in water. It'll be a solid. So you get the idea. I'm going to jump to 2 that are a little bit harder to do. These 2 at the bottom. Lead sulfate and lead sulfate. So obviously I'm not including the Roman numeral because we're going to figure it out. Normally, sulfates dissolve in water. They're right here. Except when they're with lead. So therefore they wouldn't dissolve. But the problem is it has to be lead plus 2. So the way you'd have to do this is you will have to use your oxidation state rules to figure out the charge on this lead. Now the quick way of doing it is if you look SO4 up, either on Table F or Table E, it doesn't matter. It tells you right here that it's -2 as a group. So SO4 is -2. So therefore, if you set the whole molecule equal to 0, and you have -2 from SO4, I would get -2 here. And for this one down here, I would get -4, because there's 2 of them, right? We multiply down. Then the P in the top one is going to have to be +2 to make it 0. But in the bottom one, the P is going to have to be PB, is going to have to be +4. So the top chemical, the PB is +2, therefore it is an exception. so it will not dissolve in water. It'll be a solid. And the bottom one, it is not the exception PB, so therefore it would dissolve in water and it would be aqueous. I will send a picture of this completed out on Remind. Be aware, these problems here are going to do the same thing. The same thing should happen here. One of them will dissolve, one won't. So try those, see if you can figure out which ones dissolve. Finish the rest of this. A Castle Learning will be put up for this work. And the notes will be available on Teams.